I'm going to try and explain why it is that perhaps we don't understand as much as we think we do. I'd like to begin with 4 questions. This is not some sort of cultural thing for the time of year. That's an in-joke, by the way. But these 4 questions actually are ones that people who even know quite a lot about science find quite hard. And they're questions that I've asked of science television producers, of audiences of science educators, science teachers, and also of 7-year-olds. And I find that the 7-year-olds do marginally better than the other audiences, which is somewhat surprising. So the first question, and you might want to write this down either on a bit of paper physically or a virtual piece of paper in your head. And for viewers at home, you can try this as well. A little seed weighs next to nothing, and a tree weighs a lot, right? I think we agree on that. Where does the tree get the stuff that makes up this chair? Right? Where does all this stuff come from? Okay, and your next question is, can you light a little torch bulb with a battery, a bulb, and 1 piece of wire? And would you be able to kind of draw, you don't have to draw the diagram, but would you be able to draw the diagram of how to do it, or would you just say that's actually not possible? The third question is, why is it hotter in summer than in winter? I think we can probably agree that it is hotter in summer than in winter, but why? And finally, would you be able to, and you can sort of scribble it if you like, scribble a planned diagram of the solar system showing the shape of the planet's orbits? Would you be able to do that? And if you can, just scribble a pattern. Okay. Now, children get their ideas not from teachers, as teachers often think, but actually from common sense, from experience of the world around them, from all the things that go on between them and their peers and their carers and their parents and all of that experience. And one of the great experts in this field, of course, was, bless him, Cardinal Wolsey. Be very careful what you get into people's heads, because it's virtually impossible to shift it afterwards. All right? I'm not quite sure how he died, actually. Was he beheaded in the end or hung? Now, those questions, which of course you've got right and you haven't been conferring and so on, and normally I would pick people out and humiliate, but maybe not in this instance. A little seed weighs a lot. Basically, all this stuff, 99% of this stuff came out of the air. Now, I guarantee that about 85% of you, or maybe it's fewer at TED, will have said it comes out of the ground. And some people, probably 2 of you, will come up and argue with me afterwards and say that actually it comes out of the ground. Now, if that was true, we'd have trucks going around the country, filling people's gardens in with soil. It would be a fantastic business. But actually, we don't do that. The mass of this comes out of the air. Now, I passed all my biology exams in Britain. I passed them really well, but I still came out of school thinking that that stuff came out of the ground. Second one, can you light a little torch bulb with a battery, a bulb, and 1 piece of wire? Yes, you can, and I'll show you in a second how to do that. Now, I have some rather bad news, which is that I had a piece of video that I was about to show you, which unfortunately the sound doesn't work in this room. So I'm going to describe to you in true Monty Python fashion what happens in the video. And in the video, a group of researchers go to MIT on graduation day. We chose MIT because obviously that's a very long way away from here and you wouldn't mind too much. But it sort of works the same way in Britain and in the west coast of the USA. And we asked them these questions, and we asked those questions of science graduates, and they couldn't answer them. And so there's a whole lot of people saying, I'd be very surprised if you told me that this came out of the air. That's very surprising to me. And those are science graduates. And we intercut it with, we are the premier science university in the world, because British like hubris. And when we gave graduate engineers that question, they said it couldn't be done. And when we gave them a battery and a piece of wire and a bulb and said, can you do it? They couldn't do it. Right? And that's no different from Imperial College in London, by the way. It's not some sort of anti-American thing going on. As if. Now, the reason this matters is we pay lots and lots of money for teaching people. We might as well get it right. And there are also some societal reasons why we might want people to understand what it is that's happening in photosynthesis. For example, one half of the carbon equation is how much we emit. And the other half of the carbon equation, as I'm very conscious as a trustee of Kew, is how much things soak up. And they soak up carbon dioxide out of the atmosphere. That's what plants actually do for a living. And for any Finnish people in the audience, this is a Finnish pun, we are both literally and metaphorically skating on thin ice if we don't understand that kind of thing. Now, here's how you do the battery in the bulb. It's so easy, isn't it? Of course, you all knew that. But if you haven't played with a battery in a bulb, if you've only seen a circuit diagram, you might not be able to do that. And that's one of the problems. So why is it hotter in summer than in winter? We learn as children that you get closer to something that's hot and it burns you. It's a very powerful bit of learning, and it happens pretty early on. By extension, we think to ourselves, why it's hotter in summer than in winter must be because we're closer to the sun. And I promise you that most of you will have put that. Oh, you're all shaking your heads, but only a few of you are shaking your heads very frightened. The other ones are kind of going like this. All right. It's hotter in summer than in winter because the rays from the sun are spread out more, right? Because of the tilt of the Earth. And if you think the tilt is tilting us closer, no, it isn't. The sun is 93 million miles away, and we're tilting like this, right? That makes no odds. In fact, in the northern hemisphere, we're closer to the sun. We're further from the sun in summer, as it happens, but it makes no odds, the difference. Okay, now, the scribbled diagram of the solar system, if you believe, as most of you probably do, that it's hotter in summer than in winter because we're closer to the sun, you must have drawn an ellipse, right? That would explain it, right? Except, you're nodding. Now, in your ellipse, have you thought, well, what happens during the night between Australia and here, right? They've got summer and we've got winter. And what, does the Earth kind of rush towards the sun at night and then rush back again? It's a very strange thing going on. And we hold these two models in our head of what's right and what isn't right. And we do that as human beings in all sorts of fields. So here's Copernicus's view of what the solar system looked like as a plan. That's pretty much what you should have on your piece of paper, right? And this is NASA's view. Yeah, stunningly similar. I know, I hope you noticed the coincidence here. What would you do if you knew that people had this misconception, right, in their heads of elliptical orbits caused by our experiences as children? What sort of diagram would you show them of the solar system to show that it's not really like that? You'd show them something like this, wouldn't you? It's a planet looking down from above. But no, look what I found in the textbooks. That's what you show people, right? These are from textbooks, from websites, educational websites, and almost anything you pick up is like that. And the reason it's like that is because it's dead boring to have a load of concentric circles, whereas that's much more exciting to look at something that angle, isn't it? Right? And by